Test microphone. Test microphone. Hello? Let's get started. Today we just have a look of LAB4. LAB4 should be very similar as the previous one. Do you still remember what have we done in LAB3? So in LAB3 we have like doing the data collection for this different distance in the environment of line of sight. And this time we just remain the same distance, but we will put an obstacles between the hotspot and the laptop. And we will see what happened. Let's have a look of the specification here. Can you see the specification here? Have a look of this document. Okay, so what should we do? Do you still remember what is line of sight? Line of sight here. So line of sight, which means there should have nothing between our hotspot and the receiver, right? But this time it's a little bit different. The first task is to capture the RSS data. So it should be the same as previous lab, but the condition is with and without an obstacles between a Wi-Fi transmitter and receiver. So this is the keyword. It's with and without an obstacle. So what is an obstacle? Here are some examples in the documents. A sofa is an obstacle. Here, sofa, right? And you can also choose other things as your obstacles. For example, a door or a wall. And what you need to do in this task is collect the data for fixed distance, and you should put an obstacles between the hotspot and receiver. And finally, you will get at least 500 packets of RSS data and save it as a CSV file. So you can see here, it asks us to use 3 different types of obstacles. So which means we are required to capture at least 4 data sets in this task. So what is 4 data sets? You can see here are 3 types of obstacles here. So there are 3 data sets here. And another one is without an obstacles. So there should have nothing between your hotspot and your receiver. So that's why we need to have at least 4 data sets in this task. And because we are also going to try 2 different frequencies. So you may have at least 6, right? at least six data sets. Here are some graph. Let me find it. Here. So how to collect the data? At the first time, you should put and sender, which is your hotspot. Maybe it's your mobile phone or your laptop, and the receiver, which is your laptop, right? And running the Wireshark or network monitor. And at the first time, you just collect the line of sight ISS data. And the second time, you just do something like this. You put an obstacles between them and capture another data set again. And change the obstacles for 3 times. So you finally have 4 data sets. And then you change your frequencies from 2.4 gigahertz to 5 gigahertz and do it again. So you may have like maybe 8 data sets if you are be able to create 5 gigahertz hotspots. Okay. So is this task very clear for you? Let's have a look over the question. So we should capture at least 40 CSV files. No, it is not 40. So what do you think is 40 data sets? Because you remember, because you think we need to use 10 different distance, right? So you think it's 40 CSV file, but actually it's at most 8. For the basic requirements is at least 4 data sets. So let me explain again. What you need to do is collect the RSS data with and without an obstacles. So we collect the data sets without an obstacles at first, like this. We put an sender and receiver in your home, let's say and keep some distance from the sender and receiver and collect the data at first. And then you put an obstacles between them and collect the data again. So that this one is the second data set, right? And then you choose another obstacles, let's say it's obstacles 2, and collect the data. So you got 3 data sets totally. And after that, you choose another obstacles, let's say obstacles 3 between them and collect the data again. So totally you will have 4 data sets, okay? And this 4 data sets is in 2.4 gigahertz frequencies. And if you are be able to create 5 gigahertz Wi-Fi, then you need to do it again. So do these steps again. So you get another 4 data sets. Is that clear? So there no need for 10 different distance. All we need to do is keep the same distance. So it may be much easier for you than last time. We don't need to move around. Is there any way that we improve the efficiency to capture things for Mac? It cannot play a video using the internet when I am in monitor mode. I have captured almost 10 minutes and still cannot capture 500 data. Oh, if you are not able to play a video, maybe you can use the ping command through your terminal. How about that? Did you try the ping command? Maybe we can talk it later and have a look of it. Yeah, and for some general question like this, I have already put the answer on here. Sorry, refresh, and we can see in the GitHub link, there are some general questions that you might find it useful. Okay. It's not really clear that in here. So actually, if you can, you need to submit 8 CSV file instead of 4. I will fix it later. And some general question here, I will explain later. So here are the links. And also, I upload quiz samples, and you may find it useful for your quiz preparation. So you can have a look of it. It is the previous quiz in last year. So it will be similar at the type of the question for the quiz. So maybe you should practice before you attend the real quiz. Okay. Get back to the lab. So for the task 1, let's have a look of the specification again. I'm not going to tell you how to capture the data because you have already done the lab 2 and lab 3, right? So you should be very familiar with that. So again, in this lab, we just collect the RSS data with and without obstacles. For the with obstacles, we choose 3 different obstacles, right? So we have 3 different data sets. And without obstacles, which is line of sight environment. So totally 4 data sets. And we keep the same distance. So we just use a fixed distance. And you may ask, what kind of, so what is the exactly distance I need to use? I think maybe 5 or 6 meters, but it depends on you because maybe some students have very small rooms, so they may have only 2 meters to capture the data, which is okay for us. But if you have enough space, maybe you should try different distance to have a look of the difference on the ISS data, because we consider maybe 5 or 6 meters is the best distance to capture the data. But it may depend on your interface or environment. Depends on a lot of things. So you can choose your data. You can choose your distance by yourself. Okay, just specify your distance on a report. And you also require to capture at least 500 packets in the CSV file. Right? But of course, you need to filter the packets before you save it as a CSV file. So you may capture, let's say, maybe 10,000 packets, and then apply the filter. Then you have like 500 packets and save it as a CSV file. Okay, because we are going to use these 500 packets to help us to generate the graph on the report. Sometimes when I use network monitor to capture data, it doesn't capture RSS. Yes, it does happen. For example here, I capture with my network monitor here and I open it with my Wireshark. Then you can see there's lots of packet, doesn't have any signal strength, doesn't have any RSSI. So what should I do? I just delete them. And I keep this kind of packets which have the signal strength that I can use. So after filter out all these kind of useless packets, I need to remain at least 500 this kind of useful packets in my CSV file. So maybe you need to collect for like 5 or 10 minutes. Okay. So don't put this kind of useless packets inside your CSV file. Okay, let's have a look of the second task. The second task is here, very short sentence. We just ask her to plot the RSS distribution of the previous data set. You can see here, the task 2 is plot the RSS distribution and then observe their mean values, right? And write down your observation as a commentary. I think that's all. So you can see the PDF report showing the distributions and also a table here, right? For both 2.4 gigahertz and 5 gigahertz frequencies. But the 5 gigahertz frequencies is optional because some students may not be able to create 5 gigahertz frequencies. So this part is optional. If you fail to collect the 5 gigahertz frequencies, it is okay. You will not lose any marks. But if you do have 5 gigahertz frequencies, you are more likely to get a full mark. Okay. And also a paragraph of commentary. Okay, so come to the report part. So what should we do again? A graph, right? We need to plot a graph, maybe something like this. This one is a violin graph. So you can see the graph is like a violin. So how can we know what is this? You can see it here is a single spot here, which means this is the median value of it. And then you can see the shape of it, which means the distribution of it. So which means the line of sight environment have most value, has most ISS, the signal strength is between the around 35 dBm, minus 35 dBm. And for the like human body with chair as the obstacles, most of the distribution is in these two areas, which means it's minus 30 and minus 40, right? So we can use the violin plot to identify the distribution of the data set. But it is not required to plot a violin graph like me. So you can choose any plot you want, such as the bar chart or the scatter plot or anything you want, okay? Just any graph you think it is very clear to represent the distribution of ISS. Do you have any questions? Can an obstacle block a specified frequency signal much better than other frequency? Can an obstacle block a specified frequency? Yes. You can observe by yourself. Sometimes like metal stuff will have a significant influence for the like signal strength. You can try it by yourself. Or even a piece of paper will work. Yeah, so you can choose different obstacles. So maybe you can choose A4 paper or passport, ID card, or anything you want, okay? So this is only for demonstration here. So you are not required to do the same thing as me. So you are not required to choose the obstacles here, like exactly the same. You can choose anything you want. So the second thing in our report is this table. You can see this table. there should have at least 2 columns, which is these 2 columns. Okay, the first one should describe what is your object, and the second one should be the 2.4 gigahertz, and you should write down some number here. So what is the average RSS? Then you should get some value. And if you are be able to create 5 gigahertz hotspot, then you can add another column here. Then write down the average value of it. Does that make sense? And the commentary, I have nothing to say about it. Just write down your observation. So let's have a look how to create the 2.4 gigahertz and 5 gigahertz hotspots. So at first we should know, so what is the difference between them? I think we have already learned how about the difference between them, right? In the lecture. So I'm not going to say tell you again. Basically just the distance and the speed. And how to check your frequency. So maybe you are not pretty sure what is your frequencies for your hotspot right now. So you can just right click the internet icon at your desktop at the corner, the right corner of it. And then you should be able to find the properties of it. Then you can see there's a network band. So it is 2.4 gigahertz for mine. So you can use this way to check your bands or frequencies for your Wi-Fi signal. And then how to create a 2.4 gigahertz or 5 gigahertz hotspot. So the first one is Android phone. Android phone should be pretty easy. So the Android phone, we just use just open the configuration of the mobile hotspot. Then you should be able to choose the band if your mobile phone support 5 gigahertz hotspot. But most of the mobile phones support 2.4 gigahertz. Okay. So it should be pretty easy to change the configuration in Android phone. But how about iPhone? For iPhone, if you are using an iPhone 12 rich kit, then you should be able to find the maximize compatibility here. Compatibility here. You can see if you have this button. So if you are using a newest iPhone, then you should be able to find this button. So which means your default frequency of your hotspot is 5 gigahertz. And once you open this button, then your hotspot will switch to 2.4 gigahertz. Okay. So if you are using the newest iPhone, then you should be able to create both 5 gigahertz and 2.4 gigahertz band. But if you are using the old iPhone like me, then you cannot find this button. So maybe you should maybe only you can create a 2.4 gigahertz hotspot. So if you are using the iPhone, that's okay. We just do the 2.4 one. But if you have another laptop, you have another spare laptop, the thing will be much easier. You just create a hotspot with your second laptop like this. Just enter the setting and the configuration in mobile hotspots. There should be have a configuration for that. You can select your hotspot band in here. So if you have a second laptop, then it will be much easier. Okay. Do you have any question? If we don't have any question, let's just go to the next part, general questions we have. If you are looking for get some feedback for your lab 2, then you can check it by now. The marks should be available now. Just check the submission page of the lab 2, then you can get the result of it. And the next one is a very common question. Because we are required to capture at least 500 packets in this task. So at least 500 valid packets. So how can we increase the traffic between the hotspots and our Wi-Fi receiver? The first option is like play a video when you capturing. And the second option is use the ping command. So by using the ping command, you will add at least one packet per second, yeah, yes. So at least 60 packets per minute. And the next one is some student may find their ISSI or their signal strength is in positive value. For example, like this. You can see here, the signal strength is in positive value, but in theory, we are not able to get a positive value of signal strength, so which is pretty weird. But the reason is here, because the ISSI is a completely arbitrary value. So sometimes our interface will just create value which is positive. So which means 0 is the weakest signal strength and the 100 is the most powerful signal strength. So all you need to do is to describe this problem if you have. And you are not required to change the symbol into negative. You are not required to add a negative symbol here. Okay. And I think that's all for the questions. Let's see, do we have another questions? Yeah, I think that's all I have for today. So do you have any question? So if you have any question, just feel free to stay here and maybe post it on the chat or just talk to me. But if you do not have any question, so you can feel free to leave. We will see you next week. Thank you. Thank you. See you next week.